Assalamualaikum warahmatullahi wabarakatuh. Today, I'm going to present assignment computer simulation. Our title is Simulation of Structural Fluid Flow Thermal on Any Mechanical Equipment. The mechanical equipment that we use in this assignment is copper tube that using in HVAC industry. Introduction to CFD and FEA. Simulation can assist engineers in visualizing the relevant characteristic. It can provide insight and understanding that is difficult to obtain from testing. Medical parts such as copper tube that widely used in HVAC industry can be simulated through FEA and CFD analysis to get their properties and any other behavior. The meaning of FEA and CFD is computational fluid dynamics and FEA means finite element analysis. The problem statement of our assignment is using analytical solution method to get a result of any simulation has their own limitation. So, analytical solution method are limitedly to highly simplified problem where the thermal conditions are sufficiently simple. Simulation allow user to determine how a system responds to different inputs to us better understand how it operates. The objective of our assignment is to find the structural and the thermal behavior of HVAC copper capillary tube that usually in HVAC. And our parameter is we to get displacement, tension compression, and one meter stress for FEA and the thermal analysis for CFD. And the dimension of our copper tube is we have 0.5 meter length, we have outer diameter 0.02 meter, and inner diameter 0.018 meter. The difference between CFD and FEA has a lot of difference. CFD simulation provides useful information on the underlying transport phenomena in chemicals process such as heat, momentum, or mass transfer. If you want to calculate how a fluid flow, you can use CFD. CFD provides the ability to theoretically stimulate any physical condition. The FEA also is the model can predict a structural behavior under real-world dynamic operation condition. An engineer can analytically modify the structure much cheaper, faster, and easier than he can change actual hardware.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Wafi bin Rashidi, and I'm gonna give some points about copper tube properties and dimension. About the copper tube, the length of the copper tube is 0.5 meter, and for the outer diameter is 0.02 meter. For the inner diameter is 0.018 meter. Okay. For the properties, as you can see in this table, for the molecular weight is 63.55, and then for the melting point is 1085 degrees Celsius. For the boiling point, it is 2562 degrees Celsius, and then for the density 8.96 gram per centimeter cube. For the electrical resistivity, it is 20 degrees Celsius, and lastly for the electronegativity is 1.9 Paulings.
Assalamualaikum and salam sejahtera. My name is Ashraf Arujdi bin Afendi. So for this presentation, I will explain about the finite element analysis, structural simulation of the results. So there are two types of load, which is 100 and 1000 Newton. So for the displacement, for the 100 Newton minimum has shown 0, while the maximum value is 2.962 E minus 0.3. For the tension or compression for 100 Newton, it shows the minimum is negative 9.143 E plus 0.7, while the maximum value is 8.839 E plus 0.7. Lastly is the bond missile stress for the 100 Newton. The minimum value shows 5.004 E plus 0.3, and the maximum is 9.143 E plus 0.07. For the 1000 Newton, the displacement shows minimum value of 0 and the maximum value is 2.962 E minus 0.2. As for the total compression for the 1000 Newton, the minimum value shows negative 9.143 E plus 0.8 and the maximum value shows 8.839 E plus 0.8. And lastly, the volume stress of 1000 Newton. The minimum shows 5.004 E plus 0.4 and the maximum shows 9.143 E plus 0.8. So next is the structural simulation results of 100 newtons of load. So there are three types of diagram, which is volume stress, displacement, and also the tension or compression. And finally, this is the structural simulation results of 1000 newtons of load. Same as before, it has three diagrams, which is displacement, tension or compression, as well as volume stress. Next, I will hand over to Amiruddin for the next presenter. Thank you.
Hello, my name is Muhammad Amirul Ruslan. Right now, I will explain about the computational fluid dynamics simulation results. So we have four results, which are eddy viscosity, temperature, pressure, and viscosity, velocity. So the eddy viscosity, we got here the maximum value is 1.000 exponent negative 3. The noise is 29. The minimum value is negative 8.179 exponent negative 41, and the knots is 1763. So another three value is from the result. We got pressure, temperature, and velocity. Actually, the temperature, velocity, and pressure, we got the error result because we can got the value of maximum is maximum and minimum is 4.000 exponent positive 2, and both of knots is 1. And another result is velocity and pressure. We got minimum and maximum value same, which is 0 value. So this is velocity. The minimum value and maximum value is same, and not both of them also same. The pressure which same with velocity, which is the value is same 0, the maximum and minimum value, and both of the knots is 1. This may be due to an error from us while doing CFD simulation. There are some parts that we overlook from the steps performed, or there is a problem with the software. That's all from me.
Lastly, for the conclusion, in conclusion, by using CFD simulation, we can solve complex flow equations using numerical methods, create powerful turbulence modeling CAD models, and study fluid flow phenomena. For copper, the thermal conductivity is 398 watt per meter Kelvin. This shows that copper has high thermal conductivity since copper is a lattice of positive copper ions with free electrons moving between them. These free electrons help in conduction of electricity. From the simulation, we can conclude that copper material is suitable for air conditioning system that can be handle the high temperature. That's all from me. Thank you.